In the last episode, I showed you how to create a Rails API-only application for building JSON REST APIs. In this episode, I'll show you how to add pagination to the post index API that we created. Here is the application code which we created in the last video. The application was built using Docker and run using Docker Compose, and all of the Rails command had to be prefixed with Docker Compose. I kind of feel that is too lengthy every time I need to run any Rails commands. Let's start with shortening that. I'm going to create a shell script under the bin folder and name it as d_rails and paste in some code that helps run Rails commands over Docker Compose. And I need to give it an executable permission. Now with this script, some of the Rails commands would look like bin/drails dbmigrate or drails generate model and so on. These look very much like Rails now, only the difference is that instead of Rails, you would start with bin/drails. Let's run the migration using the script bin/drails dbmigrate. I have a clean database running on another container, the DB service, and dbmigrate should create the posts table and with the title and body columns. And that's the only table we have. Let's run the Rails server, Rails S, and reload the post index API on the REST client, which should respond with a JSON body which has an empty array. Please note the API URL may or may not contain .json extension. Either way, the response should be JSON. At times, I prefer the one without JSON in the URL to save some space in the address bar. Now, before we write any code for pagination, let's insert about 100 post records in the database. Open up the seeds.rb and delete all the comments. Iterate for 100 times and each time create a blog post with some title and body. Go back in the terminal and run Rails db seed, and that should create 100 post records. Now run Rails server, reload the post index API, and that should respond with a JSON with 100 post entries. Now let's add pagination to the response. Instead of 100 records in the response, let's do say 10 or maybe 5, or maybe based on the number of entries that the API consumer would like to receive per request. For pagination, I'm going to be using this gem called Kaminari. If this gem is new to you, you may want to go through the README on GitHub. Let's open up the gem file and add gem Kaminari in there. I need to run bundle install, for which we will use Docker Compose build. Once that is complete, let's open up the Rails console to test some of the pagination scopes that Kaminari added to the active record. Post.page2. Now here, page is the scope which is added by Kaminari into active records, and it expects a page number to be passed in. And the SQL query would look like this. By default, the limit or the page size that Kaminari sets is 25, and his MySQL query has a limit 25, and the offset is 25 because we are querying for the second page of size 25. For example, if the page size was 1, the offset would have been 0, and if the page size was 3, offset would have been 50, and so on. Now let's do post.page2 per 5. Now per is another scope that Kaminari added. This means per page I want 5 records. The instruction would say query for the second page and get only 5 records. Now the SQL statement has a limit as 5 and offset is 5. Now let's take a look at some of the methods available on the active record relation, which is the return value of the scope, and I'll assign that to a variable called posts and try posts.count, which should give the number of records in the current result. Total count should give me the total number of records to be paginated. Total pages based on the page size, it will calculate the number of pages to be paginated. Next page is the next page number based on the current page. Current page is what we queried for. Previous page is a previous page number based on the current page, and the last page question mark is basically a boolean method which tells you if the current page is the last page. Exit from Rails console and run Rails server again. Now let's go back to the posts controller and change the index action to fetch the first page and 10 records instead of getting all the records in one query or the default that Kaminari sets, which is 25. So reload the API, and the response now has the first 10 blog posts. Now if I want to query the second page, or if I want to request for the second page, I would add a query parameter called page with a value as 2 and replace the hard-coded page number to read from the query parameter from the params hash, and the param is page, and if it is not available, default it to 1. Now reload the API, set the page 2, and the response has the second page or the post starting at ID 11 through 20. If the API consumer wants to set the page limit or the size in the request, I would expect the page size be in another query parameter called per page. Let's set the per page in the request URL as 5 and reload the API, but it still responds with 10, and that is because the controller has that hard-coded. Back to the controller, update the per scope parameter to read from the per page from the query parameter and default it to 10. Reload the API. The response now has 5 records starting at ID 6, and that is because the page size is now 5 and the second page starts really at 6. A quick code refactor. Instead of reading from the query parameter in the action method, I prefer moving them into a separate methods. To make it quicker, I'll paste in those method definition here. Let's take a quick look at these methods. The page method that reads the page number from the query parameter and defaults it to 1 and assigns it to an instance variable. Similarly for per page, reads from the per page parameter. Now update the index action to use these methods instead of reading from the params hash. Looks good. Now again reload the API and it looks fine. Now that we have the pagination, there's one thing that is missing is the pagination information in the response. Now we need the API consumer to know how many posts are there for the pagination or how many total pages to be paginated through. For example, if the client is using this API to render the web pages, this information is very much needed to build the pagination links. There are two different ways you can achieve this. One is by adding the pagination links as a JSON structure within the response body. Another option is to use some specific or custom HTTP response headers. So I'm going to use the HTTP response headers to set the pagination information for the API client to read from. So let's define a new method in the controller called setPaginationHeaders, which is called by the index after getting the current page data. Let's define the method. To start with, I will set the total count of posts to be paginated in a custom header called xTotalCount. Next, for the pagination links, such as next page, previous page, last page, or first page, we will be using a standard header called link. Let's take a look at an example from GitHub Developer API documentation. Here is the one for pagination. The response header will include the links for the next and last pages as comma separated in the link header. And each link in the header has a complete URL including all the query parameters and a relationship with the current page. The relationship to the current page could be next page, previous page, or last page, or first page. Now let's start with creating one link, maybe the link to the next page, and set that to the link header and test it out. URL can be constructed using routes helper for the posts, that is posts URL with all the query parameters from the current request and the new page number instead of the current page number, which is already in the query parameters. Semicolon, the value for REL, the relationship, which is next. Before we reload the API, note the response header doesn't have those headers. Let's reload and we have these two new headers. xTotalCount is 100, which is coming from the total count, and link header, which has the link to the next page, the same format as we saw in the GitHub Developer API documentation. Now we need to add the links to the other pages as well if they are available, such as last page or first page or previous page. I'm going to create a new method that would generate individual link value for a given page number and a relation text. And I call this method to set the value for the link header for the first one. Additionally, this can be made conditional, which means only set the header if there is a next page. Now we can reuse this method to create the links for other ones as well, but then we need to put them in a comma separated format. So let's start with creating an array. Add the next page if there is a next page. Add previous page if there is a previous page. Add link to the first page if the current page is not the first page. Add link to the last page if the current page is not the last one. And join them all together with comma and set it to link header. One small correction, the method to get the last page number is total pages, not the last page. Now reload the API with page equals to 10 and per page equals to 5 in the URL. And the response header link has the links to the first page, previous page, next page, and last page. API consumer now can read these pagination links from the link header and make further requests. If you notice, we didn't really make any changes to the response body. Both the total count and the links go in the response headers. Now we can make some improvements to the pagination code to make it more reusable. If you see the implementation of set pagination headers, this can really be made more reusable. That can be used by other APIs as well that require pagination. Now we can change this method to accept a paginated collection, PC I'll call it in short, and replace all the references to @posts inside the method. Also, instead of using the posts specific route helper, one can build the URL based on the current request URI and merge the request query parameters. This is just another way to construct the URL, but we'll get the exact same result. And then the method call in the index action will now pass in the collection, which is @posts, to this method, and reload the API, and it will still work. Now, instead of calling this method explicitly in the index action, maybe we can use the after action callback to set the pagination headers. Something like after action of index, set the pagination headers for posts. I can't really use the instance variable here, so let's use a symbol, which basically is the name of the variable where we store the posts or paginated collections. Let's comment out the method call in the index action. Now go back to the method definition, set pagination headers. We'll now get a variable name as a symbol to fetch the paginated collection. Let's define the same variable inside the method called PC, and I'll use this method called instance variable get for that instance variable, which is @post in this case, but we would have to extract it out of the symbol which is passed in. Reload the API, and it populated all the links in the link header. All the three methods that we wrote, page, per page, or set pagination headers, can really be used for other APIs as well that require pagination. That being said, let's move those up in application controller and make them private. To verify one more time, reload the API, and it works just fine. Now before I finish up, there is one thing that I'd like to point out, is that the Kaminari gem that we used is generally used for regular Rails applications. That means the Kaminari gem comes with a bunch of view helpers for HTML views, but those are not really useful for the API-only applications. But you can really just pick the core and the active record components of Kaminari instead of the default one and update the gem file and restart the application, and you're good to go. I will not be making that change in this video, but you may want to try that out. That's all for this video. Thanks for watching.